Alright, so today we're going to talk about the quotient rule, which involves dividing exponents. So we have 6 to the 5th divided by 6 to the 3rd. Like I always say, when in doubt, write it out. So this is 6 times itself 5 times divided by 6 times itself 3 times. We know that a number divided by itself equals 1, so we can cross off all 3 of those, and we're left with 6 squared, which equals 36. If we look at number 2, we would say, okay, x times itself 9 times 4, 5, 6, 7, 8, 9. X times itself 3 times. Cross these off, and we're left with 1, 2, 3, 4, 5, 6 x's in the numerator. Again, we'll try that one more time. We'll say x to the 8th divided by x to the 4th. We say 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Again, a number over itself crosses out because it equals 1, and we're left with x to the 4th. If you go back and look, you should notice a pattern. 5 minus 3 gives us 2, 9 minus 3 gives us 6, and 8 minus 4 gives us 4. So like the product rule was when you multiply numbers with numbers of variables at the same base, you add the exponents. The quotient rule is when you divide numbers or variables with the same base, you subtract the exponents. And again, when we say numbers or variables with the same base, we're saying these numbers have the same base, these variables have the same base. We simply say, oh, 5 minus 3, that equals 2, 9 minus 3, that equals 6, and 8 minus 4 equals 4. So very simply, for number 4, we would just say, oh, well, 8 minus 5 equals 6 to the 3rd. If we multiply that out, we get 216. 7 minus 2 gives us x to the 5th. C to the 21st divided by c to the 10th. 21 minus 10 gives us c to the 11th. 36 minus 6 gives us y to the 30th. And so you see, there we have it. Now, if you look at number 8, you may be a little perplexed because you say 6 minus 6 equals y to the 0, and you say, well, what does that mean? Well, let's talk about this a few different ways. The first thing I would say is, when in doubt, write it out. You'd have y times y times y times y times y times y, and then y times y times y times y times y. Well, if you cross them out, guess what you have? Everything crosses out, and when something is divided by itself, that equals 1. I would also say, if you look at y to the 6 divided by y to the 6, you say, how many times can a number go into itself? How many times can y to the 6 go into y to the 6? Let's say once. Again, what if we replace y with a number and we said 2 to the 6 over 2 to the 6? Well, 2 to the 6 equals 64, and you'd have that in the numerator and denominator, and yes, that equals 1. So if you go back to the quotient rule and you said, well, 6 minus 6 equals y to the 0, what you learn is anything to the 0 power equals 1. So you could have c to the 0, that will be 1. You could have x to the 0, that will be 1. You could have 5 to the 0, that will be 1. You could have 8 to the 0, that will be 1. And what I like to tell my students is this. Think about what it was before it was c to the 0. So think maybe it was c to the 9th over c to the 9th, something over itself. Before it was 5 to the 0, maybe it was 5 squared over 5 squared. The 2 minus 2, that gave me the 0. Because you know 5 squared divided by 5 squared is going to give you 1. I'm going to go down to this part where you have multiple variables in the same problem. You would say 5 minus 3 is a squared, 10 minus 9 is b to the 1st. However, we want our answers in simplest form, so we simply leave our answer as a squared b. Now, when you move to this problem, okay, I think we would say we can do the variables pretty easily. We would say, oh, well, that's going to be a to the 4th, 12 minus 9 is b to the 3rd. But what do we do with the 12 and 20? I'd invite you to come over here and say this. Let's simplify fractions for a second. When you simplify fractions, you would say, okay, well, what's 10 over 15 divided by 5 is 2, divided by 5 is 3. how would you simplify negative 18 over 12? Well, divided by 3, that would be negative 6. Divided by 3, that would be 4. Oh, we can keep going. 3 over 2. Okay? Again, we're just simplifying fractions. What if we had 18 divided by 9? That would be 2. What if we had 21 over 28? Divided by 7 would be 3. Divided by 7 would be 4. And lastly, I'll say this. What if we wanted to simplify 12 over 20? Divided by 4 is 3. Divided by 4 is 5. You get 3/5. Again, we're just simply simplifying fractions. When you bring it back over here, what I want you to notice is that 12/20 is simply a fraction. So yes, you subtract the exponents, 9 minus 5, 12 minus 9. But you treat the coefficients as fractions. So when you look at 12/20, you simplify that and say, oh, 12 divided by 4 is 3, 20 divided by 4 is 5, and there's your answer. 3 to the 4th, 3 to the 3rd, all over 5. Here again, you could separate the 6 and the 28 and say, oh, divided by 2 is 3, divided by 2 is 14, 46 minus 23 is x to the 23rd, 25 minus 16 will be y to the 9th. Again, we treat the coefficients right here as simply fractions. A couple more examples and we're done. If they divide evenly, then you divide it evenly. So 15 divided by 5 would be 3. We don't need the 1 because that's not in simplest form. So we just leave the 3, and then make sure you put a 1 down here in the denominator. 3 minus 1 gives you x squared. 9 minus 3 gives you y to the 6. 3x squared, y to the 6 is your answer. Here we deal with negatives the same way. Divided by 5 will be negative 2. Divided by 5 will be 5. 48 minus 25 will be a to the 23rd. 60 minus 10 is b to the 6th. Now, I'm going to scroll up here just for a second. Students often ask why, well, look at these, why my variables wind up in the numerator. What I say is this: if I wrote this out, I would have 1, 2, 3 x's, and then 1x down here. Then I have 9 y's, 1, 2, 3, 4, 5, 6, 7, 8, 9, over 3, 1, 2, 3. And if I cross these out, oops, change the color there, I'm left with 2 x's in the numerator, 1, 2, 3, and then I'm left with 6 y's in the numerator. Notice, my denominators, these are all canceled out, and I'm simply left with these in the numerator. Let's go down to number 6, and we'll finish up our lesson for today. Negative 20 divided by 10 is going to give us negative 2. 9 minus 4 gives us a to the 5th. 15 minus 10 gives us b to the 5th. c to the 5th divided by c to the 5th gives me c to the 0, which is really 1, and 1 times negative 2 is just negative 2. Another way you can think about that is c to the 5th goes into itself 1 time, so you actually leave the c out of your final answer. Then you're going to say d to the 12th divided by d to the 11th, which is d to the 1st, or just d. So your final answer is going to be negative 2, a to the 5th, b to the 5th, d. And that's how you do the quotient rule.